Alright, so I made a mistake in our last video, and instead of re-recording that video, probably for the fourth time, I'm just going to tell you what that mistake was, and it's right there. 9 minus 8 is 1, not -1. I assume many of you caught that earlier, but in case you didn't, there you go. What we're going to do now is talk about applications. So rational equations occur in problems involving rate and time. These are often called work problems. The amount of work is the product of the rate and the time spent working, T, or work equals rate times time. In problems that involve distance, the equation is distance equals rate times time. So you can think about work and distance similarly. Depending on the problem, you may need to solve the work equation for one of the other variables. So let's practice that here real quickly. I'll do an example and I'll leave one for you to do. So if work equals rate times time, we're going to solve this equation for T. And all I would do here is divide both sides by r. And I would get that T equals work divided by rate. And we're going to find that to be particularly useful. I want you to do this for r, so solve work for the rate. I'm going to do example 3. So it's often helpful to use a table similar to the one below to organize information. So in this example, we've hiked 6 miles from point A to B at a rate of x miles per hour. For the return trip, our rate was 1 mile per hour faster, and the entire trip took 5 hours. What is x? So in this case, we know the d, or the work, and the d, the distance, was 6 miles each way. So I'm going to write 6 miles. And we are given our rate as variables. In the first direction, it was x, and I'll say miles per hour. And in the second direction, it was x plus 1. We traveled 1 mile per hour faster in the second direction. We do not know how much time it took each of our trips, but we know the total time was 5 hours. So I'm going to say we don't know T1. I'm going to make a subscript for T1. We don't know T2. But what we do know is that T1 and T2 add to be 5. So I'm going to say that T1 plus T2, the 2 times, add to make 5 hours total. Now, earlier up above, we had a formula for T. It was the work, or the distance, divided by the rate. So I can rewrite each of those t's using the x and the 6 in their respective rows. So for T1, instead of writing T1, I'm going to write the work divided by the rate. So we will be able to write 6 divided by x. And for T2, we will be able to write 6 divided by x plus 1. And all of this still equals 5. And now we're going to solve this equation for x using the skills that we've been practicing so far. I'll give myself a little bit more room here. We'll need to have common denominators, and the first fraction has an x and the second fraction has an x plus 1. So my first fraction will need an x plus 1 in it, and we'll have to do that to the top and the bottom here. And my second fraction will need an x. Now that we have common denominators, we can write it as one thing. I'm going to try to do a better job of keeping my equal signs lined up. My denominator is x times x plus 1, and my numerator is 6x plus 1 plus 6x. Okay, I am going to continue to simplify my numerator, and I'm going to simplify my denominator by distributing. Alright, and my numerator can be rewritten as 12x and 6. All this still equals 5. Okay, I'm going to take this work up here to give myself some more space. And so I don't really like that I have 5 equaling this fraction. So I can get rid of the denominator here, which is being divided. In order to get rid of something that's being divided, what we will do is we will multiply both sides by x squared plus x. And that will cancel the numerator and denominator out on that side, leaving us with 12x plus 6. And I'm going to distribute over here. Okay, now we're going to bring the 6 and the 12 over here in a moment. And we'll have it set to 0. And once it's set to 0, we can think about factoring this trinomial. And I'm going to use that AC method in order to fill out my box. So my outer terms were 30x squared when I multiplied it. My middle term is 7x. Finding things that multiply to make 30 but add to make 7. Let's see, 1 and 30, nope. 2 and 15, nope. 3 and 10. I like 3 and 10, so negative 10x and 3x. And those are going to help me fill out this box so I can see my factors. My first term is my 5x squared, and my last term is the negative 6, so I know where those go. And now I know my missing boxes, 10x and 3x. So I'm seeing that I've got 5x times x to give me my 5x squared. I need a 2 here, it's negative, and I've got a 3 here. So now I've got it factored as x minus 2 and 5x plus 3. And I need to figure out what x's make 0. And so I will say that 0 could equal x minus 2. So x could equal 2. And I could do the same thing over here. 5x plus 3 equals 0. And subtracting 3 and dividing by 5. X equals negative 3 over 5. Okay, now this was an application question. And we were asked to find, what were we asked to find? What is x? And we have 2 x's, and x was a speed. So we have x equals 2 miles per hour, or x equals negative 3/5 miles per hour. And only one of these makes sense in this situation. And in this case, 2. Well, we shouldn't put a square around it. We should answer it in context because it was an application question. So we should say we traveled 2 miles per hour on our way there. Or I'll say trip A. You're going to do one that is a little bit easier than the one I just demonstrated using this idea. If you get stuck with your group, and this is going to be a group 4 question, I want you to open your book and check out an example that's done that's pretty similar. We're in chapter 12.5. If you look at 12.5.4, you'll see an example that might help you out. But try it first without doing that example. See if the work that I have done above helps you. All right, thanks.